Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, and good night for all of us, especially for Mrs. Eva Dameti Situmorang as an artificial intelligence laboratory assistant. So in this video, I will explain about uh, about the feature of AI. But before I start the video, I will let me introduce myself. My name is Muhammad Raka and my name is 212460061. Now we're going deep into 3D computer vision. There's three. The first is image programming. The second one is programming. The third is math, geometry, linear algebra, and optimization. First is image programming. Uh, Furthermore, image programming is essential to in the reconstruction of three-dimensional models by analyzing the visual feature and geometry relationship within the images. Algorithm can create a detailed 3D representation of object or scenes. This process involves technique like feature extraction, camera calibration, bundle adjustment, and triangulation, which collectively enable the reconstruction of a 3D environment from a set of 2D images or video frames. Object recognition and tracking in 3D space also heavily rely on image programming. By combining that information with traditional computer vision technique, algorithm can identify and track object correctly within a 3D environment. This involves detecting and localizing object in the 2D images or frames, leveraging the data to refine the object's position and orientation in 3D space. Image programming in 3D computer vision refers to the process of manipulating, analyzing images or visual data to extract meaningful information about the three-dimensional structure of object of scene. It involves applying computational technique and algorithm to process and interpret the content of the 2D images or video frames in order to reconstruct a 3D representation. In image programming for 3D computer vision, depth estimation is a key task. Various methods, such as stereo vision, can be employed to estimate the distance or the information of object in a scene. By analyzing the disparity or difference between corresponding points in multiple images captured from different viewpoints, algorithm can calculate the depth map or point cloud, revealing the 3D structure of scene. The second one is programming. Programming in 3D computer vision involves writing code to implement algorithm and technique that analyze and process visual data to extract three-dimensional information from 2D images or video frames. It requires a combination of computer vision, mathematics, and programming skill to create software system capable of perceiving and understanding the three-dimensional structure of object and scenes. One one of the key tasks in programming for 3D computer vision is depth estimation. This also involves implementing algorithms that utilize techniques like stereo vision, structural light, or depth sensor to calculate the distance or depth information of object in scenes. The programming code typically involves image processing, feature extraction, and matching, followed by disparity estimation and the map generation. Additionally, programming in 3D computer vision often include 3D reconstruction. This involves writing code to analyze multiple images or video frames and extract visual feature and geometric relationship to reconstruct a detailed 3D model of object or scenes. The remaining task may involve camera calibration, feature extraction, correspondence matching, and resolution algorithm to accurately reconstruct the 3D structure. Object recognition and 3D space are also essential aspects of programming in 3D computer vision that involve developing algorithms that can detect and track objects within a three dimensional environment. The programming code will include techniques like object detection, feature tracking, and fusion of 2D and depth information to accurately locate and track object in 3D space. Third one is math, geometry, linear algebra, and optimization. Mathematics plays a fundamental role in 3D computer vision, providing the theoretical foundation and tools necessary to analyze and manipulate three-dimensional visual data. There's three key mathematical areas in 3D computer vision are geometry, linear algebra, and optimization. Geometry Geometry is crucial in understanding the spatial relationships and geometric properties as properties of object and scenes in 3D computer vision. Concepts such as points, lines, planes, angles, and detail, distance and transformations are utilized to represent and manipulate the geometric elements. Geometric Geometric transformation include translation, rotation, and scaling are essential for aligning and registering 3D data. Algorithm for camera calibration, stereo vision, and 3D reconstruction heavily rely on geometric principles to compute accurate depth and 3D structure from 2D image of or video frames. Linear algebra is essential for handling and manipulating the mathematical representation of objects and scenes in 3D computer vision. Matrices and vectors are used to represent and operate on various elements, such as image pixel, camera parameter, and 3D points. Linear algebra technique enable transformation, projection, and computation involving these mathematical entities. For example, matrix operations are commonly used for camera calibration, solving linear system in 3D reconstruction, and performing coordinate transformation. Optimization methods are employed in 3D computer vision to solve complex problems and optimize object function. Optimization 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 algorithms such as least square, maximum likelihood estimation, or bundle adjustment are used to refine and optimize the estimate parameters such as camera poses, depth maps, or 3D models. This technique minimize the error or disparity between the observed data and the computed or reconstructed 3D representation. Optimization Optimization plays a critical role in improving the accuracy and robustness of various tasks, including camera calibration, 3D reconstruction, and object tracking. The second category is 3D computer vision about application. The first one is augmented reality. Usually we can hear that AR. Uh, Second one is virtual reality, it's a VR. And the third one is visual mapping, and last one is autonomous vehicle. The first one is augmented reality. Augmented reality or AR is an exciting application of 3D computer vision that enhances the user perception and interaction with real world by overlaying virtual content in AR. Uh, 3D computer vision plays a crucial role in enabling immersive and experiences by providing accurate depth perception, object recognition, and spatial mapping. One important aspect of AR is registration, as 3D computer vision algorithms are used to precisely and align and track a visual object or with the real-world environment by analyzing visual feature and geometric relationship. AR system can ensure that virtual content appears fixed in space and seamlessly blends with the user view. The second one is virtual reality. Virtual reality or VR is another compelling application of 3D computer vision that creates immersive and interactive simulated environment. In VR, 3D computer vision plays a vital role in providing a sense of presence and realism by accurately rendering and interacting with virtual content. In key aspect of VR, 3D computer vision is rendering realistic 3D environments. Computer vision techniques are used to model and render virtual scenes, including object, texture, lighting, and shadows. By leveraging 2D computer vision algorithm, VR system can create the visually compelling and immersive virtual world that user can explore and interact with. Third one is visual mapping. Virtual mapping is important application of 3D computer vision that involves creating the digital representation of real-world environment in 3 dimensions. By leveraging various computer vision technique, virtual mapping enables the generation of accurate and detailed 3D models of physical space. One key aspect of virtual mapping in 3D computer vision is the process data capture. This involves capturing visual data from different sources, such as photograph, video, or depth sensor. Computer vision algorithm analyze and process this data to extract geometric information, texture details, and depth cues. Techniques like structure formation, simulation, calculation, and mapping, or SLAM, or leader scanning are often used to reconstruct the 3D structure and geometry of the environment. The last one is autonomous vehicle. Autonomous vehicle represent a sampling sampling application of 3D computer vision, where the integration of advanced perception system enables vehicle to navigate and operate independently. In this context, 3D computer vision plays a crucial role in providing the necessary environmental awareness for as autonomous vehicle. One key aspect of 3D computer vision in autonomous vehicle is object detection and tracking. By leveraging that information from technique detection and tracking, by leveraging that information from techniques such as lidar or stereo vision, computer vision algorithm can accurately detect and track in the vehicle surroundings. The identifying pedestrians, vehicle, and sorry, and other potential obstacles, enabling the vehicle to make an informed decision for safe navigation. Next, we have a 3D sensor. The first one is Kinect. The second is lidar, and the one is radar. The first one is Kinect. Kinect is a sensor technology developed by Microsoft that combines RGB or color imaging the depth sensing capabilities, offering a wide range of applications, including gaming, virtual reality, and computer vision. Kinect utilize a combination of cameras and depth sensor to capture both visual and spatial information from the surrounding environment. In the context of computer vision, Kinect sensor provide valuable depth perception, allowing for accurate and detailed 3D reconstruction by using structure light of time of light technique. Kinect can be measured the distance to object in the scene, generating depth map that represent the spatial layout of environment. This depth information enables such applications such as gesture recognition, body tracking, and 3D scenes reconstruction. When next to LIDAR, which stand for light decision and ringing, is a powerful sensor used in variety of application, including autonomous vehicle, where it plays a crucial role in processing the surrounding environment. LiDAR sensor utilize laser beams or to measure the distance and create high resolution 3D maps of the surrounding. In the in the context of autonomous vehicle, LiDAR sensor provide the accurate and detailed depth perception, enabling precise object detection and localization by imitating laser pulse and measuring the time it takes for the pulse to bounce back after hitting object. LiDAR sensor can generate precise distance measurements. This information allow autonomous vehicle to build a comparison understanding of their surrounding, detecting objects such as vehicle, pedestrians, cyclists, and obstacle with high accuracy. Last one is radar. Radar is a key sensor used in various applications, including autonomous vehicle, where it plays a vital role in providing essential information about the surrounding environment. Radar, which stand for radio detection and ringing, utilize electromagnetic waves to detect and measure the distance, velocity, and direction of objects. In the context of autonomous vehicle, radar sensors are employed to enhance perception capabilities, particularly in challenging weather conditions or low visibility scenarios. Radar system can be detect objects such as a vehicle, pedestrians, and obstacle, allowing a vehicle perception system to gather crucial information for safe navigation. So this is where I got the material, and that's all of my material. Uh, there's some words, the consonants of the sky that will become a destiny of our love, makes the expense that this witness this second in the ultrafine light that begins to be shaded by green day will be uh, will be the cranberries of our love become real with my girlfriend. Thank you so much for watching, guys. That's all I can explain to you. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih.